My name is Dan Thayer. I'm with Logical Advantage. I'm one of the co-founders of the company 12 years ago. And if you've been to our website before, you've noticed that all the marketing and branding has changed. We now have this really cool logo where it used to look really cool but different like that. And we changed everything to let everyone know that we're changing and we're specializing more. Because our message in the past has always been, you have problems, we've got solutions. And that's still our message, but we're more targeted. And our mission is to partner with our clients to provide strategies and solutions that maximize their ROI on enterprise asset intelligence and human capital development. And so that's part of the Internet of Things is a real expertise area of ours that we're growing our business in. And enterprise asset intelligence, we've done a lot of distribution and asset tracking type applications that are our specialty. There's our mission statement. And we're also always hiring people. And right now, we're about to hire a BA. And so if you know anyone who's a business analyst who's really good with consulting experience, now's a good time to tell us, because we're going to pull the trigger soon on someone. We're also looking, but we're looking for people on the BA side who can do business process modeling and can lead conversations at meetings. We're looking for devs. You don't need AngularJS, but if you have that experience and experience with a web API, C#, then that's great. We're also doing a big game development project, and so if you have experience with Unity 3D, then that would be really good. And we always have lots of staffing opportunities, so if you have a skill set on here and you're looking for a job and it's not here, then still contact us. You can contact me or our recruiters, and if you contact me, I'll just forward it on to our recruiters. And we started this really awesome group called Charlotte IoT. Steven's one of our members. And we've had 3 meetings so far, and we've got over 100 people in our group. The next meeting is February 3rd at Snap AV. And if you go to the meetup site, you can find information on it. But the February 3rd meeting will be the same talk that I'm giving today, but I'm going to bring more toys, and so it'll be like a little bit more fun than today, but the same talk. And the other thing is it'll be filled with IoT people who just are fun to talk to. So it's always good just to come to the meetings to talk to them, even if you already know the content. I'm going to talk about now for what is IoT, just in case you've not heard of it. But everything in our cities and are becoming smart, and our things are becoming smart, and it's happening because of inexpensive microcontrollers. That the microcontrollers can be on the network, or can talk via Wi-Fi or radio. All kinds of improvements where the price is going down. There's all the wearable technology, and so there's all kinds of new opportunities now with the Internet of Things. And the value of the Internet of Things, it's either in data or control. So Logical Advantage has always done projects around data. It's kind of our specialty, acquiring data and visualizing it and doing stuff with data. So now with the Internet of Things, it's just using a microcontroller. Maybe not this one, this is the big one. That's the Galileo. But using a microcontroller and sensors to collect data and talk to a service to do something with it. And then control is the other aspect, where you can push messages down from a server to make something local do something. And we've got projects that we've done on both sides. One project we did for Pratt Miller was around data acquisition. And Pratt Miller is a big engineering company, and they're big into NASCAR and IndyCar racing. And this project was for IndyCar. And they built these IoT stations, they're weather stations, and they put them on all the corners of the racetrack and on the straightaway. And so we measure like the wind and the temperature and all kinds of weather data. We built the data acquisition service that these devices are sending sockets messages to, and we're just collecting the data and displaying it real time so that engineers can look at this and they see, oh, the wind is this speed on this turn, and they can communicate that to the drivers to tell them how to like go into the turn, or information on the temperature. It's hot on this part of the track, so the tire is going to behave differently. And so this getting real-time data to the racing is like key to finishing first. And they've got these devices on all the IndyCar tracks, so not just one track.
And that data share with all the drivers?
No, hell no.
So what's everybody's just putting up their own devices on the track? I mean, how's that?
Yeah, I'm sure if you've got relationships with the track, then other teams could do that. So General Motors pays Pratt Miller. Like if you see GM racing, it's really Pratt Miller and some others, but mostly Pratt Miller. And so they're helping specific teams to win. They're not like sharing it with everybody. We did a project for Rubbermaid Medical up in Huntersville, and it's a medical cart. And on this medical cart is a touchscreen display, and nurses log into it, and based on the ID of the nurse, it'll set the cart's height. And the main purpose of the cart is to monitor the battery. The battery is powering the laptop, and she's just running normal hospital software on the laptop. But they need to know, the whole fleet, what's the status on these carts everywhere in the hospital, and so they can check the UI on the web to see where their carts are and what the status is of the battery, so they can manage it better. And they're going to be adding features such as controlling when the nurse can get medicine out of the cabinets, and the doors will be locked, and she'll enter the code and unlock the doors.
Why don't you bypass the keypad and something like Beacon?
Beacon? I have to talk to you about that. I don't know really much about that.
Oh, I'm deep into it, so.
Oh, sweet. Yeah, we'll definitely talk. That's
That way when she walks up, it already knows who it is, the whole 9 yards.
that would be sweet. Yeah, that to me is the neatest feature on a lot of cars. When you walk up to the car and the car unlocks the door and you don't have to get your keys out. Yeah, that's like the, to me that feature is almost as good as the camera on the back. There's like a few features on a car that are neater than everything else, and that's one of them. So I'd love to talk about that. I've been working on my own home automation system now for probably 4 years. And it all started with a squirt gun, where I wanted to be in the office and squirt the kids while they're playing in the pool. And this picture in the upper left shows the squirt gun. And essentially what it is a hose with servos on the end that can target it. And I first wrote it for a UI on Windows Phone 7, where I'd stream video to the phone, and wherever you would touch on the phone it would spray, but it sucked. With the buffering time and whatnot. I built other UIs later that are way better. One of them is a Connect UI, and the Connect senses it has an API that tells you the coordinates of your skeleton, all of your joints. And I use that information to know where you're pointing at in the pool. And then with the other arm, when the wrist becomes higher than the elbow, it actuates the trigger, and you can spray. There's a video on YouTube you can watch on that. And then I built the garden, where it just waters the garden. And really that's real similar to the squirt gun. The only difference is it doesn't have a servo on the end. But I think it would be really cool. You could make a watering system in your yard that you could move the hose around and target. I've added 4 zones in the garden now, and the garden has these really cheap solenoid valves that you can buy at Lowe's or Home Depot. They're like $12. And the same valve I'm using for the garden I'm using on the squirt gun.
Did you steal the controller from the Orbit?
Well, you don't even need a controller, because the solenoid valve,
The solenoid valve on the Orbit is pretty much just a valve with 2 wires that pretty much allow you to turn it on and off.
Yep, exactly. Yeah, so I'm using a relay, and The solenoid valves, they're meant for AC power for the input, and I forget what it is. It's somewhere around 12 volts or something AC, turns it on. And but you can also actuate it with DC. I'm using DC for air, and I just have a relay that the microcontroller turns the relay on and off to route the power to the solenoid through that. The next project I did is the garage door, and this is like 4 years ago, before everyone had all the garage doors online. And the mistake I made on this is I ran wires from one microcontroller. So in my office is the microcontroller, and there's wires that go out to the pool underneath the house and go to the garden underneath the house. And the garage was a hard one to get to because I had to go underneath the house and then up a wall and then over the attic. And finally I made my way to the garage. And so what I learned on that is make everything smart so you don't have to run wires everywhere. So each one of these should have its own microcontroller, and then it's more flexible if you go to move and whatnot. I probably had the first IoT fireplace, and it's a little dangerous, but I know. And last weekend,
The
insurance company doesn't know. Luckily, I don't watch YouTube. But
quick question: Are you actually firing? It's propane fireplace.
It's a gas fireplace, and I'm using a solenoid valve, and I'll show you the code in a little bit. That
Okay, they make standard. You can buy them at Home Depot. The light switch kit.
yes,
Why don't you just intercept that signal with the switch versus the?
you absolutely could. Those switches are like RC, probably, and you just have to send the same signal.
Yeah, that way you're at least protected down at the gas.
The gas line, yeah. No, I'm using. We bought this at either Lowe's or Home Depot, and it had a different type of controller on it, and I just replaced the controls with my own. And what I did was I got an H-bridge controller that is made for a like an RC car. And H-bridge means the motor usually spins one way, but with H-bridge you can make it spin the other way as well. And with the solenoid valve, you have to actuate it in both directions. So you turn it on, and you just let it in a resting state, and you turn it back the other way. And so it only took 2 pins on the Arduino to control the H-bridge, and then that talks to the solenoid. So this is what I was talking about earlier, because my wife is talking, every now and then she brings up, well, let's move, and I've become invested in the house because I love all the IoT toys everywhere, and I don't want to move because of the stuff in the house. And so now when I'm building new projects, I'm making each thing individual as a unit, kind of like this Christmas tree here, where it plugs in and you can take it with you. It's a one unit. So at Halloween, I do a lot with the Internet of Things, and the ghost in the coffin actually turns its heads as the kids are walking down the sidewalk, and it looks at the kids. Has everyone seen this video? I've got a video on this. This is the only video I'm going to play that's a repeat of other videos. All the other ones are new, but let me show you this one. So one thing cool, I wrote an article on the code project, and now on Google, if you type in IoT home automation, it's the first link that comes up. That's not an advertisement. Did I lie? No, yeah, here it is, the first one.
You can spell it and still showed up.
Sweet. I can never spell anything. So, yeah, I entered the, they had a contest where they were giving $1,500 to the best Internet of Things project. And so I went all out and wrote this super long article, but they gave it to someone else that he did a robotics project. To me, I thought he was fourth place. I don't know why he got first, but he was still really good. So I've got a couple of videos on YouTube. I'll go ahead and play the second one. It's a little newer and shorter. Hi, I'm Dan Thayer, CTO of Logical Advantage, and this Halloween I've been having a blast with my Arduino and Connect. If I move around, you can see up here the image follows me, and even better, the ghost in the coffin, he pays attention to me. When I look down, he's down, and up, he's up. So it's kind of a fun thing. And let me show you the mobile app. Now here's the mobile app. The best feature on it is the scare button. And catch on top of the bush. So you notice that the skull launched off, and I call that the launcher. That's the new feature this year. And I'll show you how that works again. So I've had a blast. Some of the kids got really scared by that, and that was like the best part. But I'm Dan Thayer, CTO of Logical Advantage, and wait until you see what I do next year. So at Halloween I've got 5 different things that are controlled by the Arduino, and this year I added an air scare where I'm using the same valve I'm using for the garden and the squirt gun. It's a $12 valve, but I went to the hackerspace and those guys were building rocket launchers. Thanks. With the valve, so I realized that you didn't need to spend like $80 on a pneumatic valve. You could get something, control air cheaply if you're just doing something for Halloween on a cheap valve made for a garden system. And so the kids and I, do we have any extra chairs? No, sweet. We built the rocket launcher with air, which was really fun, but then I retasked that launcher on Halloween, so it was had an air pipe going through the bush, and I put a bracelet so kids would walk up to it and reach for it, and when they would get close to it, the Connect would sense that they were close to it, and it would send this puff of air out. I think it opened it for like a half a second, 500 milliseconds, and it shot the air out so fast it sounded like a gunshot. It made like a sonic boom, which is cool because then I had other things in the yard that were sound activated, and it looked like the whole yard was like IoT stuff was happening, but really it was just the 5 monsters near each other with the coffin. It was fun. One of my other Arduino projects, which we talked about earlier, was the fireplace, and there's a video on YouTube. The unique thing I did was I made a QR code that has the URL. When you scan the QR code, then the Arduino will actuate the solenoid and ignite it, so it's a self-destructing QR code. And I think I'll show you some of the Arduino code so that when I show you like Arduino or some of the Spark core code, you can compare the difference. I like showing the fireplace because it's really simple code. Do I need to make that bigger? All right. That's maybe too big. Okay. So up on the top, I've got the privates that are some variables that are going to output pins. So if you look at the Spark core code later on, it's similar where you basically have all the pins on it and you have to tell the microcontroller what are you using the pin for. And in this case, I'm using them as digital outputs, but I'm using analog pins. But through the code, I'm telling them I'm going to use this as an output.
What does that mean, analog and digital pins?
So you can use a pulse width modulator, which is regulating the length of a pulse to, like, if the pulse is on half the time, then it's equivalent to having half the power on the pin because it's pulsing so fast. And based on it pulsing, I used to have a slide that explained how pulse width modulation worked, but if it's on half the time, then and you're powering a light, it's basically looks like it's half as bright.
I've actually had to describe this quite a bit.
Yeah, let me hear what you.
So if you look at a straight line, you can imagine that's 100% power at all times. So you want to start breaking that line, turn it into a dashed line. Okay. Each one of those dashes now becomes a pulse. So the longer the dashes and the closer they are together, it's closer to 100% power. Shorter the dashes, further apart they are, it's less power. So if you want 25%, and you take a full line like this, you break it into 4 pieces. So now it has 4 positives. That's an easy way to think of pulse width.
So you would take 120 volts down.
No, we're not talking voltage at this point in time. We're just talking about the flow of voltage. So no matter what it is. In this particular case, we're down on DC voltage, though. 3.5.
Right.
100
So-
milliamps.
Use time to control the amount, the duty cycle, how long it's on versus off. And 100% is be on the whole time. If you want 50%, it's on half the time, off half. So
I can show you back here, Jay.
Think of a
You
light
start with
switch.
5. Would you have 2.5, or what would you have?
No, you'd
Yeah.
have 5 for half the time and 0
So
for the other.
if your
So
output-
you're really taking the switch and turning it on off as
Yeah.
fast as you can.
If your output's 3 volts, if you have it on all the time, if this is time,
Yeah.
then it's on all the time. But then if you have it on half the time,
Always good for the electronics, though.
if you have it on half the time,
That's how to do a lot of LED control. Because LEDs.
the average amount of power is in the middle here because it's pulsing on and then off and then on and then off. But then you could pulse it so it's just on like 25% of the time, and the average power would be down below. That kind of makes sense. So they call it analog output, but really it's a pulse width modulator that you're. You can put a capacitor and some other things to make it more average, but you're really just turning it on and off.
Too big, and you really have to jack it and start it in full.
With the capacitor will hold the voltage somewhat. It'll slope down with time, but
You can call it analog because you can set multiple values. If it's a digital output, you can only have on or off. An analog output, you can have from 0 to 255 or whatever, 1028, 490.
Yeah.
So you can set the output level, you can set a number and say, okay, whatever this thing is doing, pulse width modulation with green, the D to A, digital to analog, you can set the output voltage that way. That's they're using that now.
so and then the pins can be input where you could send in a voltage range that it can read that range of voltage and give you a number back for how much voltage are you seeing. So that's how you would measure like the temperature in a room. You get a resistor that varies based on the temperature, and you can measure the voltage and then compute the temperature from that. So anyways, back to the fireplace. I've got properties, and the properties are basic properties that are like turn on, turn off, calling the method to turn on. So if you set it on, it's going to call this turn on method. I'll go to the definition on that. And earlier I talked about the H-bridge controller, and there's 2 pins, and when you write the one pin to turn on, you have to make the other one be the opposite. And so this is just saying turn on the solenoid, wait 2 seconds, and then turn it off. So when it's in the resting state, there's no power on the solenoid. So for the gas, it just moves it and then rests. The off is the same type of logic where it just moves the solenoid in the opposite direction and then turns off. So if you look at this, it's really simple code that all it's doing is turning on a power to some pins that are talking to the H-bridge circuit, and I bought that circuit from SparkCore, which, not SparkCore, but SparkFun. I thought that was the best company to get SparkFun to make something for the fireplace. But SparkFun, if you don't know about it, they're like Maker Shed and some of the other good places to buy fun gadgets and microcontrollers and things. I'll show you the Halloween code. It's a little bit more more to it. And you notice that over here on the right, I've got class files. And one good thing about the Arduino is that it's object-oriented, and you can write really good code that has leverages class files and object orientation, where we'll look at some of the other microcontrollers that aren't object-oriented and don't allow you to structure your code as nicely as this. So here's where I'm defining what all the pins are doing, and the thank you. And so the I'm using a relay to control the zombie. So there's a zombie on the ground that rubs the ground, and at Party City or someplace one year we had this zombie that we'd purchased, and rather than just using the controls that came with it, then I hacked it and just power it through a relay. And let's see, the skeleton. The skeleton is a ghost that jumps up in the air at the kids. It's spring-loaded. And the skull motor is like a bat that hits the skull that's on a string. The string's connected to the top of the house. And if you notice here, I've got the input. So the way that the skull motor works is it's a spring-loaded motor. The motor turns in one direction, and there's gears missing on the end of it. So when it gets to the end, there's no gears, and so it releases its hold on the bat, and it hits the skull. But there's a limit switch that then it hits on the way back, so it knows that it's done. And so that's how you do an input. So these are all the properties. And I send messages whenever you set a property on and off. And I've got a desktop messenger application that you have up that just receives messages and tells you what's the state of everything in and what's it doing. It helps with troubleshooting, but it also makes like a nice log. I know when people in the house turn on lights and do things or come home. So the kids, don't tell them, but I can track them. And if they come home, I know when the lights are turning on and what they're doing.
Our lights only work in one direction. They never turn back on.
Yeah, yeah. So
user input.
They're broken for everybody except for me.
So that's one of the niceties of the Internet of Things, because if you write your own stuff, you can turn the light off after a certain amount of time or do something with it. So let me go to the methods. So like move to position. Since I'm using object-oriented code, I wrote a servo class, and then the servo is what does the pulse width modulation. So you basically tell it an angle, and it moves to that angle. And I added a pan tilt class, which is just two servos that are in a polar coordinate system. And so like to move the ghost head or the squirt gun, I'm using the same pan tilt class, and I'm able to reuse it. It's one of the niceties of object-oriented code that you can do on the Arduino that you do it a little differently on some others.
And why you just input the amount of turns the servo has to do to get it to go certain degrees, and that's how you calculate it.
So the servos, you're doing pulse width modulation on the pin, and so it's basically what we drew on the board, where if it's going to be all the way 180 degrees, then the duty cycle will be full on. If it's the other way, it'll be full off, and then something in the middle will be in the middle. And so the nice thing is I wrote the servo class once, and then I didn't have to go back and think about it anymore. And I put all that code on the code project. So if you go to my first article for Arduino and Connect, you can grab that code and use it if you want to. So then there's a pan tilt class, and then move to position will just go to a position that's in a coordinate system that's polar coordinates. So this is telling it to go home. So when it goes home, it knows have a config area where I put what those angles are for home, which is basically 90 degrees by 90 degrees. But when you make the skeleton jump, I'm basically turning on the relay, and then I wrote some really nice time features that can call callback functions methods. And so this is saying that in 100 milliseconds, call that function. And it's really good when you write your code like this because it's multi-threaded and you're not waiting. It's like I'm controlling 5 different devices, monsters and things with the same microcontroller, and I'm not waiting on one of them before I'm doing something else. So it's really nice. The Arduino does real threaded coding where some of the others aren't. So you get the idea here. Oh, the no method is pretty fun. So on the phone, if I've got buttons that say yes or no, and if they're nice young kids who, or actually if they're older kids and they ask for candy, I'll click no, and the ghost in the coffin will shake its head saying no, no, no candy for you. And the nice kids, I'll say yes, and it shakes its head yes. And all it's doing is telling it to go through these positions of the head and to sweep. Earlier at the setup, I'd tell it the speed to sweep on the servos. And the scare method is really nice. So if I want to create like a big effect that's controlling, this is controlling 4 of the devices, I run this method, and there's a button on the phone that it makes the zombie, it says move for 20 seconds, so it's just rubbing the ground during the whole scene, and the skeleton's jumping up, and then it says launch the skull. So the skull, that's where it hits the bat, but it's going to wait 4 seconds before it actually hits the bat. That's what the time delay will do. And then it's moving, this loop here is moving the head and the coffin around. So while this is moving around somewhere 4 seconds into it, it'll launch the skull out. So this is running on the .NET micro framework. You notice this is C#. If you wanted to, you could also do VB. I don't think really many people are doing VB, but they built it into it, so you could. The air scare. So I was talking earlier about what I added this year with the compressed air opening. So if you look at the code, there's barely any code, and I think about like how much benefit I get where it makes that big pow noise, and it sends a 110 pound, it's like a punch of air at the kids through the bush. And that's all of the code that it took to write it. So I feel kind of bad that I didn't have to write more code for that. So the time to scare, usually I have the Kinect, like on Halloween I use the Kinect to control everything, but the Kinect's not sitting outside all the time because I worry about kids stealing it and whatnot. So I've got a function that I can just run this where it'll start making things move at random. And it picks a random number between 0 and 7, and then based on that it'll execute the methods that make it do stuff. And then at the end I use my time function that says pick a random number and between 10 and 30 seconds and delay for that period of time before calling the same method back. And so then I use just a private variable that if you're using you need to be able to turn off the recursion. And so on the handheld or on the mobile phone, if you click the button to turn it off, then it just sets that private variable to off. That kind of gives you an idea of how that stuff works. Really, the only hard code was the Ethernet communication, which wasn't really that hard. But if you want any of it, it's all in the code project.
Socket code?
Yeah, it's all socket code. The cool thing is I wrote it when the Arduino first came out, so the Arduino has like great forums that has tons of examples and tons of libraries you can download, where Arduino didn't have anything at that time. So mine was one of the first articles that had all that stuff, and so on the code project it got like a lot of views. I got a little over 200,000 views now on it. It's been kind of surprising to me that so many people in Google had it like top ranked when you were searching Arduino for a long time to send people to it. Come on. The cat toy is something I built, and I almost brought it in, but it's a huge pain because it's really not that big, but it's just a pain to carry. And if you look at it, I'm using a inside here is an Arduino microcontroller, and I'm using an Ethernet bridge, and this is on the bottom of it here, and it's a real pain when you have to move it from one network to another, because you have to get your laptop in and you have to plug into it, and you can reprogram it to another network. Where the Spark core that I'm going to talk about in a little bit, you don't need any wires to change the network that it's connected to, which is just like a dream. Every time I open this up, all the guts just fall out, and then you have to figure out how to pack it back in there. And it's not like it's a real product that is made well. It's just a bunch of crap that I stuffed in the box, and so it becomes hard to move around. But on this, I've got servos here that are moving a laser around on the floor, and then servos here that are moving a mouse. Let me show you that video. Hopefully it'll actually work this time. Did I plug in Ethernet?
Yeah.
All right. Yeah. What's the off on this? What'd you say? Nah, thanks. I don't, yeah. Went brain dead for a second. Here's my cat toy. Where's the video? Ah, here we go. Hi, I'm Dan Thayer, CTO of Logical Advantage, and I'm going to demo my cat toy. The cat toy has a laser and a puppet mouse. I can control it with gestures. I'm pointing to the laser and doing the gesture to turn it on. On the floor, the laser is moving. It moves in a random pattern with random speed and has a random time delay in between changing directions. You gotta love the dog. He's so into it. I can also control it with speech commands. Or cheating. Yeah. Wait for the laser to stop. Alice, move mouse. Now the mouse is moving. And underneath here, you see there's an Arduino microcontroller. The microcontroller is connected to an Ethernet bridge, so I can send messages to it over the internet. On the TV is the UI that I use to control the Connect. So it's showing you what am I pointing to. I'm pointing to the lamp now. I'll do the gesture to turn the lamp on and turn the lamp off. I can control other things in the house as well, like the fireplace. And being that it's Christmas, I'll do the gesture to turn the tree on. I've got a mobile web interface. I go to the cat toy, and I'll hit the button to move the laser. So if you look on the floor, the laser's moving. I'm Dan Thayer, CTO of Logical Advantage, and there you have it. So one of my favorite articles on the code project, I'm using vectors from the Connect to figure out what it is you're pointing to. And there's some really fun math. If you guys are into like three-dimensional math, that's a fun one to read. All right. So the Arduino Plus, it's got some strengths where you can debug in Visual Studio. So what I mean by that is you can put breakpoints on it and you can see the value of variables, and it's really nice. You can write object-oriented code and you can write real threaded code that's really good. Its weakness is it's huge. Well, I call it huge, but it's the size of the standard Arduino. I'm sure. Oh, here's one of the Arduinos, and compared to the Spark core, which in here it's much smaller. And this is not only the microcontroller, but it's the Wi-Fi circuit. And you've got one nice.
Everybody wants to look at it.
Yeah, please do pass that around. And the other negative is it's $60 compared to the new Photon that's coming out is $19.
29 is the buzzword that I got too.
Sweet.
The IoT meeting they were handing out for free.
Yeah,
So,
it was awesome.
come out.
At our IoT user group, we got 10 Spark cores. And so the one that I'm using for Christmas, I got for free. So this Christmas tree project, it was like dirt cheap. I'll talk about it later, but I made a 20-foot tree with a Spark core microcontroller. That part was free. Everything else I already had, so it only spent like $50. If I were buying everything fresh, it would be a little over 100. But still, to make something so cool and fun, so cheap is pretty amazing. IR toy, I've got several of them in here somewhere. But it's a microcontroller I'm using that you talk to serially over USB. And here's some of them. It's got a PIC microcontroller on it. And for me, I'm using a broker to talk to it. So it's like my goal to use a Raspberry Pi or some other device to talk to it. But for now, it's just plugged into a PC that I've got a web API to. And through the mobile interface, I can change the music or change the channel through it. It's pretty nice for quick and dirty home automation projects. And something else that's really good is there's a website, LIRC, that has all the infrared codes for any device that you can think of, all the manufacturers. It's open source and it's on SourceForge. And in my code project article is a link to that. But you can download those codes and then have really simply be able to talk to it through USB. I'm going to talk about Spark core now. And let me play this video. Hi, I'm Dan Thayer, CTO of Logical Advantage, and this Christmas I've been having a blast with the Internet of Things. If you look over here, you see a 20-foot Christmas tree that I built. I did this with two 10-feet cast iron pipes, and it's hammered in the ground. And there's 12 strands of lights wrapped around the poles, and all those strands are fed into a circuit that's controlled by the Spark core microcontroller. The Spark core, I'm really excited about this microcontroller. It's got a really small form factor, but the best part about it is you flash the program over the air. So what that means is the tree is on the network over Wi-Fi. So I can be anywhere with my laptop that I have an internet connection, and I can program the tree. I can change the pattern, make it do really whatever I want it to do. And that's really liberating that you can deploy code from anywhere. Let me take you over this way and I'll show you what the circuit looks like. So if you look at the tree now, it's doing a fade pattern, and the tree has 12 channels, but there's only 8 pins on the Spark core that are used for analog. So there's 8 pins that you can do pulse width modulation. If you look at it now, the whole tree is fading in and out, and it's fading in and out on all 12 channels. And so I wrote my own pulse width modulator in the software. And it's a little bit crude, but it's effective enough to do the effect well. So inside here, you can see these solid state relays. And each of these, this is a bank of 8 solid-state relays and then a bank of 4. But the brains of everything is this little guy here. That's the SparkCore microcontroller. And each one of these solid-state relays is going to a pin in the microcontroller, and it's just turning it on and off into a whole bunch of patterns to look pretty. So I could look at this all day long because the patterns are mesmerizing. So one other thing that's really neat about this is it's modular. What I mean by that, there's one plug that goes into it that's controlling this whole circuit. So at the end of the Christmas season, I'll take the tree and put it in the garage, and then next year when it's time to put it back in the ground, I'll put it in the ground and plug it in, and it's good to go. So having this thing smart and having all the logic as part of the unit is really, really neat, and what the Internet of Things is all about. I did a few other Internet of Things in the yard, and I'm going to go to the mobile app. And if you look at the snowman over here, I'm going to turn the snowman off. And over here I can do things like the wreath and the icicles. And on the chimney over there, you can see Santa, and I can even make him go away, or Santa has to come back. So I can do all kinds of really neat effects. And with doing things on the network and making things smart, you can really start to do some cool things. And a lot of people are doing music, but they're not, everything in the yard's not smart. So you get all kinds of options you have when you can talk over Wi-Fi. So you can tell every smart thing in the yard that the song's about to start and what song's about to start, and then each device can run the right program for that song. And so I'm going to have a blast next year on kind of coordinating things in the yard to dance to the music. I'm Dan Thayer, CTO of Logical Advantage, and there you have it. So this, the Christmas tree project, probably the most amazing thing to me was how easy it was. So I really did it over 2 days. I did it over 2 weekends. One day I built the tree, and I just got everything I needed from Lowe's. It's just a piece of cast iron pipe with a plumber's fitting to connect 2 of them. So this pole is really twice as tall, and it's just going into the ground. And I already had the solid-state relays, and so when we got the SparkCore through the IoT group, it's like, wow, I can actually build something like this weekend, and it was nice for that. Here's a close-up on what that circuit looks like. And the SparkCore has a new product that's coming out, and it's going to be shipping in May. It's the Photon. And the form factor of the Photon is the exact same as the SparkCore. So if you make it so that the same circuit board it plugs into with SparkCore, the Photon is the same. But the Photon is better in a few respects. Like it runs on 802.11n, also not just the B and G, and it's got more flash memory. So flash memory is basically memory on it that is still there when you unplug it, but it's slow memory. And so like the code that you run will be on flash memory. And so I'm really stoked that for $19 you can buy the SparkCore or the Photon and do a lot of really cool things. It's half price, way cheaper than like a Netduino. And let me show you what that coding environment looks like.
I think they're out in June now.
June? Nah.
Yeah, mine comes next month, or March, I mean.
So if you go to the Spark build, I already have this on the network, and getting it on the network was a beautiful process. And I told you about how it was with the cat toy. We had to plug in the laptop to it. For this, all you need is either an Android or an iOS device, and you download their native app, and with their native app you enter your Wi-Fi credentials, and once your app knows what it is, then it talks to the SparkCore and tells it what the Wi-Fi credentials are, and then boom, it's on the network. Yes?
If you are an iOS developer, you can download from TI the actual iOS code,
Oh.
the backbone of their iOS app,
Yeah.
which will give you the ability to rebrand it and everything else for yourself.
Nice. So a lot of the configuration tools, you do it in Node. They made it so that you can run SparkCore if you have Macintosh or Windows or Linux. So a lot of the configuration you do in Node, you can set up your own service with it. It's really cool. Here's what the code looks like.
The initial connection to the device before it's on a network.
So before it's on the network, you've got an LED here, and it blinks in a pattern that says you need to claim the core. And claiming the core either will go really straightforward and easy, or it'll be extremely hard. And I ended up replacing my access point at home to get it to work right. But I had extra access points from the office, so I just brought one home, and it worked well. If it doesn't work right, then there's a manual process to claim the core through Node. You basically have to, it's a much harder process, but you can still get it on the network.
So does it just scan the open Wi-Fi networks and try to automatically connect?
No. It's
BLE.
Oh, okay.
you connect with your phone, and then once your phone knows the native app on your phone, you enter in the SSID and.
So infrastructure mode, like I have thermostats at home, so you have to walk up with your iPad to a thermostat, connect directly to the thermostat, then tell it where the Wi-Fi is at.
Yeah, once the app is connected on the network, then it sends that credentials to the device.
Okay, so the initial connection is the Bluetooth Low Energy.
Is it really Bluetooth?
Wi-Fi.
I thought it was
How
Wi-Fi
do you
too.
connect it? Does it already have the
No, it's not Wi-Fi. It's not even an ad hoc, is what y'all are thinking. It's
Yeah.
actually a Bluetooth signal that it's operating off of in the beginning. When you first find it.
And then you give it the credentials for your Wi-Fi, and then
Yes,
goes
then it
online.
knows and you get online.
Okay, I was thinking it was doing a radio signal from the phone.
It was spoofing its
I guess not
Wi-Fi.
Bluetooth.
Yeah, my thermostats for Wi-Fi.
Where-
Yeah.
I could be wrong.
Because with one of them I use my laptop and it doesn't have Bluetooth now.
Yeah, and I'll Google it after this meeting.
You know, when you use the iPad, you'll use the laptop.
All right. So how do I make this enlarged in Chrome? What's that?
Scroll up.
Alt plus. Control scroll. Here we go. I did it Control plus. So at the top of it, you basically have your variables, and I'm defining names of things. And so these are the pins on the SparkCore. And then the setup runs once. And you basically tell it, just like on the Arduino, you had to say this is an input or an output. So for this, it's kind of boring because all 12 of them are just digital outputs is what I'm using the pins for. And a lot of you guys have probably done Arduino. And Arduino has the same thing where it's got a setup and a loop. And basically on startup, it calls the setup. When it's done with that, it calls the loop, and it just recursively calls loop until the end of time. And so whatever you put in the loop is your code. The IDE of this, you notice that I'm using it in Chrome. At first it didn't work well in Chrome, but I think they've made updates to it where it's working well in Chrome. So you used to have to do it all in IE. So I'm selecting it. I'm going to comment out all this code, and we'll deploy a change. So let me show you like one of these methods. Shift tree left. Let's look for that. So here's the shift tree left method. All it is booleans for each tree. So you send it a 0 or a 1. And all I'm doing is moving it. I'm holding it into a variable, and then copying what was in tree 2 to tree 1, tree 3 to tree 2, and then at the end, the one I'm holding, I'm copying it back to 12. And so and then just looping through how many times do you want to go. So if you loop through 12 times, it's going to move the light 12 times. So we'll do that. So we'll say shift tree left, and then basically we just have to enter in, actually why don't I just copy the top one. So basically it has one LED, or not LED, one of the channels on, and it's going to move that channel 12 times all the way across. So yeah, right, 200, you could set, if you wanted to go slow, you could make it go really slow, or however fast you want it to go. So I'm going to click Flash, and Flash is sending the code update to the Spark core. So you notice it's blinking real hyperly now. It's loading the new program. It's really cool that it's deploying it over the air. I don't have any wires connected to it. The negative to it is the time that it takes to deploy the code. So if you're a real iterative developer, then it's faster if you're working on like an Arduino, and you can just deploy it real fast and test it and deploy and test. But the fact that you can deploy over the air is super nice. Like the day I was coding this, it was raining outside, and it's winter and cold, and it was nice not to have to be outside in that mess. So now you can see that little simple pattern that's just moving through the different channels. The Spark core takes DC power, so I'll go ahead and, on the inside, I just hacked one of the old Linksys power supplies, and this power supply is powering the Spark core and then the solid state relays. Yeah. Yeah, luckily I don't have any nerves in my hands, so I can't feel it when I get shocked. A little bit dangerous too, but.
Does it have a recovery if you lose communications when you're flashing?
So if you would, I don't know, I would just reflash it if it didn't.
So it won't get stuck.
Yeah, it does. It times out after a couple minutes, and I've had Wi-Fi issues or something, and it just, yeah, you can just resend the program.
One issue with the Spark core is that if you don't have Wi-Fi, it seems not to work. Like it wouldn't move.
Oh yeah.
Wi-Fi connection.
Yeah, I need to look into that too, because you're storing it in flash memory, so the program should be on it regardless when you cut power and turn power back on. And you're right, because like when we didn't have Wi-Fi, it wouldn't turn on.
Maybe you have Wi-Fi control on it, so maybe just the default settings, or is it trying to get a Wi-Fi connection in blocks, and you might be able to say don't do Wi-Fi and try it later.
One other thing that's kind of interesting in this is the fade. So rather than just having a state of each channel being on and off, I made it so it has a state between 0 and 10. And let's see. Find the fade method. Here. So the fade method is real simple. You give it a value between 0 and 10. 0 is off, 10 is 100% on. And what this loop will do then is it's going to count from 0 to 10. And when I was drawing the pulse width modulation circuit on it, this is a crude way to do that, where it's going to count to 10. If you have one channel set to 3, then it's going to be on for 3 of those counts. If you set it to 4, it'll be on for 4. So you can control how bright it is. And they can do some really cool effects where you can like fade part of the tree in a circle or fade the whole tree in and out. Really simple effects. So it's like just a little bit of code to make a neat effect. And the reason I did this over using pulse width modulators is you only get 8 pulse width modulators on the Spark core, but I have 12 different channels I'm trying to control.
It's fast enough to do PWM on all those channels without any.
Yeah, so actually it's really not doing pulse width modulation. It's just my hacked up version of it by the for loop counting from 1 to 10 and being on. If it's set to on, then it's on for the first count. But I also have a delay in between. Yeah, it's effective. It's just not using like the pulse width. Yeah, the hardware.
There are alternatives to pulse. I mean, not really, but there's this like pseudo-random thing that was done years ago.
This was, yeah, nice and dirty. I also have like the milliseconds. So the light tree method that we looked at earlier. Wait, that's the shift tree left. Wrong method. Let me go to that. So it's actually in between counting to 10. It's holding it for 5 milliseconds. Just a really short amount of time.
So there's 10 levels of brightness in the phase.
Yeah, exactly. Yeah. Technically 11 because it's 0 through 10, but I didn't want to make it 1 through 10.
Do you know about the zero crossover or the solid state relays?
Yeah, no. I just know that I was shocked that it worked as well as it does. In here, I don't have it turned on. The fluorescence light pulsing, you can kind of tell it's pulsing, but at home, at night, it looked like a real fade. Let me put the code back in. You can see it. Oops. Yeah, the IDE is pretty weak, but it's nice that you can deploy over the air. That makes up for any weakness. Oops.
It looks like they're going for an Arduino.
Yeah, it is. It's the same sketch type language. That you have on Arduino. You've got your loop method and your startup, just like on.
I think INO might even be the current Arduino.
It is.
I'm deploying the code to it now. I almost wish that the case was glass. I put the case over, you can't see the LEDs, and that's almost as cool as the Christmas tree. Yeah, that'd be nice. I really didn't spend any time on the code for it. I probably spent 4 hours, and that's probably it. But there's not much to the code either. The Spark core, this is the screen I was talking about earlier that you enter in the SSID and the password. And then when you click connect, I need to look into how is it actually talking to the core, but it's sending your credentials to the core and then it's on the network. And then one other cool feature of the core is Tinker. And Tinker is a way that it gives you a UI on your phone that you can turn pins on and off, which I don't really use because it's so easy to write code, but if you were afraid of writing code and you just wanted to turn pins on and off or see what's the value of a pin, it's good for that.
That's cool. So you can throw little modules out. Can you kind of customize it? Like you want to do a robot controller?
Yeah, whatever you'd want to do, you can do on it. This is exposing the 16 pins on it, and you basically, if you have a pin, then you have to tell it, I want to treat this one as a digital read or digital write.
Yeah. They have a web API where you can use, like, on a server or your own web page, where you can send commands out that will be effective turning on these pins. So you can go the other direction. Instead of taking data.
Yeah.
This thing can publish data that's happening, like it has sensors that's picking up the inputs. It can publish it to their cloud, and then from there you can serve it to your web pages, and then you can go the other way around. You can put data into their cloud, they'll find your device, and then you can activate something. Like sending it, you can send it like, it's limited to what you can do in terms of the amount of calls you can make and the kind of data. I think you can send strings like 600 characters long.
Yes.
So 600 characters. Pretty much do anything.
I'm going to talk about some other design patterns that I've learned. And one of the useful ones is it can be a pain to maintain code for all your different microcontrollers. And so it's a good idea to let the microcontroller look up its identity and then have switches on the code based on what its identity is. We're going to 130, right?
I guess just one.
To 1? Oh, I've got to talk fast then. And so I've got 3 Arduinos at home, and it looks at the MAC address and then has switches on based on who it is. But a better approach would be to use DHCP on the Arduinos and then have it look at its MAC address and send that to an identity service and have the identity service talk back to it and say, this is your responsibility, and then put switches in the code based on what your responsibility is. And that way you have one code base for your whole fleet of microcontrollers, and it's easier to maintain. So one of the design patterns, and one of the common ones people do, is make your device a server. And the negative of doing it that way is if you're talking on the internet, you have to open up a hole in the firewall so you can route the request to the server. And it's really, you could maybe get away with this if you're doing it locally on your network, but if you're doing it on the internet, it's not a smart way to do it because of security. The other thing is your server could, or your client could be trying to send it requests faster than it can process it, and it can hang up. And so there's no way you can throttle the server on the microcontroller. You can easily cause it to seize or have issues. Making the thing a client is really good if you're sending data to a service. And you notice that it can talk to a service without opening up a port on the firewall. And the negative of this approach is your thing is tightly coupled to the service, so it knows how to talk to the service, and that's all it really knows how to do. Another approach, if you want to get around having a hole in the firewall, is have your thing poll the service. And if you do that, it can call the service and then get data from it and then respond to it on the way back. You can use a technology like long polling or WebSockets. And if you're using MQTT, it has it baked into it. Excuse me. Baked into it. See, yeah.
Have you tried to remotely deploy code?
I mean, other than on the Spark core?
In other words, like with the Spark core, you
Yeah.
have it where it's identifying itself. It pings the cloud, and it gets what it's going to do from there.
Yeah, so this could be at home or anywhere, and it's on the network, so I could deploy code to it.
Well, I understand that. I'm not referring through the Spark core
Oh,
API.
yeah.
I'm referring to...
Oh, yeah. No, I haven't done it outside of...
I haven't tried it yet either, but I'm thinking what you were talking about with MAC addresses and everything.
Yeah.
Is it's basically got some basic core code that it identifies itself, pings your cloud server, your APIs.
Yep.
And it goes, and whatever you've assigned to that API for it to do,
Yeah.
it now pulls that code down. And
So you could have it pull down like a different branch of code for each device, but the way I have it set up for my home automation stuff is the same code is on every device. And I have a configuration setting that I can, like on this device, this pin is input, but on this other device, it's an output. And so based on the device, the software will update itself.
I'm just thinking with devices that have small memories and whatnot, you can't always deploy big code base to everything.
Yeah, that's
I
true.
think this does have an API where you can send your own code base to it.
The Spark core does. I'm thinking of a little bit different thing, but yeah, Spark core does. I know it has that capability.
Yeah, and it's also amazing too that the microcontrollers, they're so cheap, but they have so much RAM on them and so much flash space that I've never even come close to running out of memory on these at least.
The memory is probably to collect data. Right?
Yeah. Yeah, like the
I mean, if you lost your network connection, you'd want to collect data and hold on to it until you had a chance to
yeah, you could store it and queue it, and
You'd be surprised at how fast log data builds up, especially near.
yeah, you'd want to use like a micro SD card or something to store if you needed big RAM.
One of the questions that's interesting about the Spark 4 is you're doing a battery-powered device.
Mm-hmm.
Because the native mode kind of consumes a lot of power to maintain that Wi-Fi connection.
Yeah.
And to be smart about it, so if you're battery-powered, have powers up every once in a while. I haven't looked into what kind of support.
I want to look into that too. I'm building a solar-powered boat, and I was thinking about using a spark core. Because what I wanted to do is, if there's a leaf in the pool, I want it to steer towards the leaf and pick it up. But I don't want it to drain the power too fast. I'd like to see how it does that. So this picture shows using a broker to talk to things. So the things are getting out of your network through a broker, and this is what I'm using at home. So the broker wouldn't necessarily have to have a hole in the firewall, but I drew one here because what I'm doing, I do have a hole in my firewall where I'm routing web requests to my web API, and you can design it so that the broker is doing a polling type architecture that it's not doing that. I'll show you a picture of that. It's really nice having a broker to talk to. Have you used MQTT? So Mosquito is an open source broker, and they actually have cloud hosted ones where if you do like less than a certain number of transactions, you can do it for free. And MQTT is a protocol written for the Internet of Things to have really lightweight messages. And I'm getting ready to update all of my code to use that. And like there's an MQTT library for Spark Core you can use. And you can go to NuGet and download one.
Serialization, so it's really small.
Yeah, it's really small. You can download one for .NET. So this is the ultimate good way to do communications, where you have a broker on both sides of the firewall, and the broker is doing a polling type architecture to where there's no hole open in the firewall. And the nice thing about this architecture is if one broker is down, then it can still function. So if your local broker is down, it can connect to the one on the internet. And if the internet is down, you lose your internet connection, you still have your local devices that can all talk to each other through the broker.
So it's a service bus.
Yeah. And this is nice for like when you have devices with different protocols. Like at home, I've got Z-Wave, and I also have the infrared device where you could have one broker that is then dispatching messages. You can have a publish and subscribe model, just like a service bus, and MQTT is got that built into it, where you can subscribe to a topic, and then you publish to that topic, and only those devices listening to that topic will process those messages. So here are some of the lessons learned that I have is make everything smart. So you don't have, if you move, then you don't have wires in the house that make it really hard to move. Over-the-air updates are really nice and really quick to deploy code, and it's going to lend itself to you writing features faster. I like the idea of having an identity service to where you have one code base on a fleet of different microcontrollers, and you read the responsibility of that microcontroller and act on it. And lastly, a publish-subscribe model is a great way to loosely couple all your devices, because you may not even know what all you're going to do to a certain topic, and later on you add a device that listens to that topic and can process those messages. Some of the funny things I've learned is don't play too much with your family. So with the IR, I was so excited when I first got it to work, and I could control the TV and radio, and I was in the office and I was just messing with them and changing the station, and I would put stations on that they don't like to watch and things like that. Well, when I came home, my wife had dismantled it all, and I still haven't even put it back together. And so I guess my lesson on that is, even though you can, don't play too much. And also be careful with fire, because the cat was playing with the mesh, and even 2 weekends ago figured out a way to defeat. I had it meshed in where I thought the cat couldn't get in. Somehow she got in the fireplace, And it was during time I was debugging some of my Connect routines, with gestures, and sometimes the gestures are unpredictable and turn things on. So it can be dangerous, but now I've got my mesh that's like bolted in. There's no way the cat's getting in now.
So you're filming Christmas Vacation too?
Yeah. And then also with the squirt gun, I spray the snot out of the kids constantly, and now they just ignore me. It's like I'm not even there, so that's no fun either. And the last lesson learned is the family is worse than customers. They don't tolerate defects at all. So when you're building home automation system, you have to make it perfect. And an example of this is the garden. I've had times where the garden wouldn't water, and my wife gives me a call and says, "You have to come home right now. The garden's not watering." I'm like, "I'm in the middle of a meeting. Can't you just use the hose?" But so what I've learned is if you're going to build something, it has to work nearly 100% of the time. And I used to have an issue on the Nejuino where it would have thread blocking and would lock up. And I finally wrote a routine that recovered by rebooting the Nejuino, and it just made everyone so much happier with all the home automation stuff. And so just getting it out there is only half the battle. Of making it reliable is just as hard as the initial deployment.
You got like a background thread that says if you don't call me back, it's on you're alive at this time, just assume everybody's dead and reboot.
Oh, like a heartbeat? You could do something like that, yeah. I'm not going to go through the rest of my slides. They're extra bonus that I put in here in case we had extra time. Yeah. Yeah, so any questions?
I just thought it was interesting to compare this to the electrician.
Yeah. The imp I found really interesting. I'd never seen one before the IoT meeting. And what I thought was cool is the IDE has, this is the client code and this is the server code, and it had it all in one window. And the other thing about the imp is Ben knows the one of the evangelists on the imp side, and he's arranging for the IoT group to get some of the amps to play with.
So just some things I noticed was the imp will run when you turn it off, even if it doesn't have it.
Very nice.
So we use the internet to program the robot, but then we just like click it on and it works.
Nice.
So that is nice. It's really fast to set the program. I mean, click run it and do it.
Oh, it deploys really fast? For big programs too, or?
I never noticed that. I mean, we're doing small programs, so I've never noticed it.
I also would like to know about power consumption. How good is it compared to SparkCore?
That I don't know, but it does power down its LEDs. After a period of time, it goes pretty quiet. So.
Yeah, the other thing is right?
20 milliamps. And those white ones will be 60.
Yeah. I'm just using incandescent lights on these. Those green ones.
You got that RGB LED?
Yeah, oh yeah. Okay. Because it's 3 LEDs in it. Okay. Awesome. Well, that's really all I have. Feel free to come play with my toys. I've got a bunch of different microcontrollers in here. An Edison and a Galileo and a bunch of others. Fun toys in here. Feel free to look at them. Thank you.